Okay, here we go again. Another test review. So let's get to it. First section we have to work on is arc length. Remember that the formula is S equals R times theta. So for this one, number one, I'll just use my space over here. We start off with the formula S equals R times theta. Arc length is S, so that's what we're looking for. The radius is 15. And the central angle is pi over 3 radians. So what we do is 15 times pi over 3. The 15 and the 3 reduce to 5. And we multiply by the pi, so we get 5 pi. Because the radius is in feet, the arc length is also going to be in feet, so we have 5 pi feet. Number 2 is S equals R times theta again. Here it tells us that the arc length is 12 pi. So we get 12 pi is equal to the radius times the central angle. Okay, so the central angle here is in degrees, so we need to convert that. So we convert it by multiplying it by pi over 180 degrees. And so this reduces to 3 pi over 2. They both have a factor of, well, 10, 4. No, that's not right. Not 3 pi over 2. Let's see. So 10's factor there. So if we 3, oh boy. Don't do math pre-lunch. Okay, so let's go to the calculator. There we go. And let's actually do that. So what are we doing there? 12 over 18. 12 divided by 18. 2/3. I was close. Okay, so 2 pi over 3 radians. Wow, that was an adventure already. So we know that this arc length 12 pi is equal to R times 2 pi over 3. So what we can do is we can actually multiply this by the reciprocal. So 3 over 2 pi. And if we do that to one side, we have to do it to the other side. And so actually when we do that, these two cancel out. So we're left with R. Change back to blue. R is equal to the pi's cancel. And the 2 and the 12 reduce to 1 and 6. So we just get 18. So radius is 18. Again, arc length is feet. So this is in feet as well. Let's go to purple and do this one. So again, another one, S equals R times theta. Arc length is 20, radius is 5, and we want to find theta. Quite simply, we divide both sides by 5, and we get 4 is equal to theta. So that is 4. It's already radians. Don't put a degree symbol because it's not degrees. It's just 4 radians. For extra security, I could put rad for radians, but I don't need to. Right, and then finally arc length, again, is 12 pi. So we get 12 pi is equal to the radius times the central angle, which is 3 pi over 5. And yet again, what we can do is we can multiply by the reciprocal, 5 pi over 3 times 5 pi over 3. And what this does is it isolates the variable r, because this cancels out. And we get, not 5 pi over 3. That should be 5 over 3 pi. So this right here is also going to be 5 over 3 pi. There we go, that looks a little bit better. And so now when we multiply this, the pi's cancel out. The 12 and the 3 reduce to 1 and 4. So we get that the radius is equal to 20. And again, feet. So here's the work. I mean, it's really nice if you start off each question with S equals R times theta, plug in the variables you know, and then just use a little bit of algebra to solve for the rest. Sector area is very much the same sort of approach. We know that the formula is A equals theta divided by 2 times r squared. This is the same thing as 1/2 theta. So with this, for number 1, we get that the area is equal to 1/2 of theta. So we multiply this by 1 over 2. So we get 5 pi over 6 times r squared, which is 81. 81 and 6 have a common factor of 3. So the 6 reduces to a 2. Pi stays the same. And 81 divided by 3 is 27. So 27 times 5 is 135. Let me just double check that again because I am doing math on an empty stomach. 135. Cool. So we get 135 pi over 2. The radius is in miles, so the area is just going to be in miles squared. And that's my answer. Okay, number 2. Same deal. We are going to be taking theta, dividing it by 2, which is the same as multiplying it by 1/2. So area is equal to 3 pi over 2 times 1 over 2, which is 3 pi over 4, times r squared. R is 17, and 17 squared is 249. 289. I really should know that. 289. Now, 289 is not divisible by 4, so we're just going to have 289 times 3, which is 867. So we get 867 pi over 4. And again, if this is in miles, the area is just miles squared. And that's our answer. For the next one up, number 3, they give us the theta in degrees. We need to multiply this by pi over 180. We need to convert this to radians. And so the 270 and the 180 have a common factor of 90. So this is 3 pi over 2. And so the area is going to be equal to 1/2 of 3 pi over 2, which is 3 pi over 4, times the radius squared, which is 81. And so we're going to have 81 times 3, which is 243, pi over 4. And this is in yards, so we get yards squared. And that's the answer. And then finally, again, we are given degrees, so we need to convert this into radians. So we should know that this 60 degrees is going to be pi over 3, but in case we forget, we multiply by pi over 180 degrees, and we get 60 over 180, which is 1 pi over 3. And so the area is going to be half of that, so we multiply by 1 over 2 to get pi over 6, times the radius squared, which is 64. 6 and 64 do have a common factor of 2. So 64 divided by 2 is 32 pi over 3. And this is inches squared because we're talking about area. So again, know the formula. Sometimes people are confused when dividing that fraction by 2. But again, that's just the same thing as multiplying by 1/2. Okay, here's some good questions here. To convert from degrees to radians, remember, we make that a fraction over 1 and multiply by pi over 180 degrees. We can cancel out the zeros first, so we get 66 over 18. We can divide that by 2. So first off, it is a negative, so we put negative. And we would get 33 pi over 9. And yeah, that can't be reduced. 33 is a factor of 2 primes. Oh, no, sorry. 3 is a factor. So I can actually change this to negative 11 pi over 3. Of course, that is in radians. Next up, and we have negative 525. And again, we multiplied this by pi over 180 degrees. And so pi over 180 degrees, 525 divided by 180. Well, 525 definitely has a factor of 5. Oh, and that's 105. 180 divided by 5 is 36. So we would get negative 36 pi over, negative 105 pi over 36. 105 is divisible by 3 as well. And so 105 divided by 3 gives us 35. So we reduce this to negative 35 pi over 12. And that's what it stays as. So just some nice little division there, but again, just multiply by pi over 180, and that'll work. When we're converting from radians to degrees, we want to multiply by 180 degrees over pi. And what that does effectively is it cancels out the pi's. So here we have a negative again. 25 times 180, don't worry about that quite yet because 180 divided by 6 is 30. And so we have 30 times 30 times 25. 3 times 25 is 75, with the 0 on the end is negative 750, and that's in degrees, so we get negative 750 degrees. I'm just going to make that negative sign look a little bit prettier, and there we go. And then again, same thing over here. I'll choose a different color so it doesn't blend in with number 6. And multiply by 180 degrees over pi. Same sort of deal. This is going to be 30 because that reduces to 1. The pi's cancel out. So 30 times 19 is going to be 270. 19 times 30. 570. I was right with the last two. All right, so 570 degrees, and that's it. So again, these problems you can see are a little bit more calculator heavy, but again, just know it's pi over 180 or 180 over pi. Okay, here we just want to find the 6 trigonometric graphs or values for all of these. So we're going to have sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and finally cotangent of theta. Lovely. Whoops. Sorry, I'm just trying to copy this. There we go. So it's going to get a little busy in here, a little tight in here. But again, some of these values we should already know. So for example, 3 pi over 2. Okay, 3 pi over 2. If you think about what the unit circle is, 3 pi over 2 is right down here. And this is the point 0, negative 1. So the sine is that y value, negative 1. The cosine is 0. Tangent is y divided by x. So negative 1 divided by 0 is undefined. Cosecant is the reciprocal of negative 1. So that's a negative 1. Secant is a reciprocal of 0, which is 1 divided by 0, or undefined. And cotangent is x divided by y. So that's 0 divided by negative 1, which is 0. Nice one there. 5 pi over 4, if I think about where that is, 5 pi over 4, this is pi, which is 4 pi over 4. So 5 pi over 4 is down here into quadrant 3. So that's going to be, sine is going to be negative, and that's negative root 2 over 2. cosine is going to be, cosine is also negative root 2 over 2. When we divided negative root 2 over 2 divided by negative root 2 over 2, we get a tangent of a positive 1. The cosecant is just going to be the reciprocal of this. So if we take the reciprocal of negative root 2 over 2 and flip that into negative 2 over root 2, we can isolate or rationalize the denominator by getting negative 2 root 2 over root 2. And the root 2's cancel. So we get negative 2 root 2, over, sorry, I'm trying to rush through this, which is not recommended. That's negative 2 root 2 over 2. Root 2 times root 2 is 2. And so those 2's cancel out. So cosecant is just going to be negative root 2. Secant is going to be, again, a negative root 2. And then the reciprocal of positive 1 is, again, positive 1. Okay, sine of 11 pi over 6. That's really close to 12 pi over 6, which is in quadrant 4. Whenever you have pi over 6 is going to be root 3 over 2. So the sine is negative, and so that is negative 1/2. Cosine is positive root 3 over 2. Tangent for this one, and I can do my little scribblings. Actually, I'll do it up here. So tangent is going to be y over x. So that's y, which is root 3 over 2, divided by x, which is times the reciprocal. So we actually get negative square root of 3. So negative square root of 3 for the tangent. Cosecant is the reciprocal of the sine, so that's a negative 2. Secant is the reciprocal of cosine, so that is root 3 over 2, that's a reciprocal of root 3 over 2, which is 2 over square root of 3. And if we multiply by root 3 and root 3, we get 2 root 3 over 3. And that can't be reduced, so we leave it as that. Cotangent is going to be 1 over negative root 3, which would be negative root 3 over 3 when I reduce it. Rationalize the denominator. And then I have 2 pi over 3. So if I use my unit circle again, think about where that is. This is pi, which is 3 pi over 3. So 2 pi over 3 is going to be, about there. And this is where its cosine is negative, so cosine is going to be a negative 1/2. Sine is positive, and that's a positive root 3 over 2. Tangent is going to be y, which is, and I can do that up here again. I guess on the top of the page. Whoops. I was just trying to scroll up. Okay, so tangent is y divided by x. It's sine divided by cosine. So sine is root 3 over 2 divided by cosine, which is times negative 2 over 1, which is going to be a negative root 3, making me realize I did tangent wrong for the last one. Sine was so that means the cotangent's wrong. Sine was negative 1/2. And so if we multiply by the reciprocal of cosine, so 2 over root 3, we get negative 1 over root 3, which we have to multiply and rationalize the denominator by multiplying by root 3 over root 3. So we get negative root 3 over 3 for the tangent. And the reciprocal of that would just be negative square root of 3. So here tangent is, we're getting that negative square root of 3. So we can see that the reciprocal here, the cotangent, would be negative root 3 over 3. Cosecant would be the reciprocal of 3 root 2, which would be 2 root 3 over 3. And the secant would be the reciprocal of negative 1/2, which would be negative 2. Some very, very nice work. The difficult part for a lot of people is the tangent, cosecant, secant, cotangent, rationalizing denominator, multiplying fractions. Those are some nice algebra skills you need to keep working on, but the sine and the cosine should be committed to memory at this point. For these problems, when we have a terminal side, this radius is not 1, so we need to remember that x squared plus y squared equals r squared. So here x squared is 3 squared plus 4 squared is equal to r squared. And actually what I'm going to do is I'm going to write down my 6 trigonometric values for all these again. Could be a little bit intensive with the square roots. Right, so we have 9 plus 16 is equal to r squared. That's 25, so that means that r is equal to 5. So the sine is going to be 4/5. The cosine is going to be 3/5. The tangent is going to be 4/3. Cosecant is going to be 5/4. The secant is going to be 5/3. And the cotangent is going to be 3/4. Over here, we're going to have x squared, which is 4, plus 49. So that means that r is the square root of 53. So sine is going to be y over r, so 7 over root 53. So that will give us 7 times root 53 over 53. Cosine would be 2 root 53 over 53. Tangent would be, again, y over x, so that's 7/2. Cosecant would be root 53 over 7. Secant would be root 53 over 2, because that's just r over x. And then cotangent would be 2/7. Here, same value actually as number 1 there. R is going to be 5, because when we square negative 3, it's still positive 9. So the sine is going to be 4/5 again. The cosine this time is a negative 3/5. Tangent is a negative 4/3. Cosecant is not a negative. It's just a reciprocal of the sine, so it's going to be 5/4. Secant is going to be a negative 5/3. And then the cotangent is going to be a negative 3/4. And here we're going to have 81 plus 1 squared, which is 1. So we get the square root of 82. I do not believe there are any perfect squares factors, so r is equal to square root of 82. So the sine is negative 1 over root 82, which is going to be negative root 82 over 82. Cosine is going to be 9 root 82 over 82. And then the tangent would be y over x, so negative 1/9. Cosecant would be r over y, which would be negative root 82. Secant would be a root 82 over 9. And then the cotangent would be a negative 9 over 1, or negative 9. So you have that packet of notes, so make sure that you know them and review these formulas. Remember, you have to find r, the radius, in order to correctly solve those. Reference angles, we're just looking for this little sliver there. So this is 2 pi, which is 36 pi over 18. And if we have 37 pi over 18, and we want to get to 36 pi over 18, we could subtract to get pi over 18. Over here, this is pi, so that is 12 pi over 12. Starting to lag here a little bit. We want to find this distance, so we can say, all right, well, I've gone 17 pi over 12, and I want to get to 12 pi over 12. So that leaves me a reference angle of 5 pi over 12. Down here, this is 9 pi over 9. Common denominator is what I'm looking for. And if I've already gone 11 pi over 9, and I want to get back to 9 pi over 9, that means that this distance right there is equal to 2 pi over 9. Number 12 is a little bit tricky because we go around a few times, and so this is, if you notice, we go to 2 pi, to 3 pi, and then around again to this distance there. So this is pi, this is also 3 pi, this is also 5 pi. And this is 2 pi, 4 pi, 6 pi, all the even pi's. So here, if we just do this, this is pi, the reference angle would be huge because this would be 6 pi over 6. Oh, sorry, these are the even pi's. This would be 12 pi over 6. If I find the difference between these two, it's going to be large. It's going to be 11 pi over 6, which is almost there. This reference angle should always be between 0 and pi over 2. So this is also the same as 24 pi over 6. That's another revolution around the circle, which you can see we go around another time. So how far apart is 24 pi over 6 from 23 pi over 6? So this reference angle is going to be 1 pi over 6. And that's what the answer is. Number 12 is a little bit more difficult. It's a little bit more conceptually difficult because it deals with coterminal angles. I will not ask you for more than one revolution on the test. So if you do 9, 10, 11, then you're in solid shape. Speaking of coterminal angles, we're going to look at coterminal angles right now. And so we want to add and subtract to find a negative and a positive. So here we are going to add 24 pi over 12 to get 25 pi over 12, and we're also going to subtract to get negative 23 pi over 12. So these are the two reference angles there. Here we're going to again add and subtract 2 pi. That's a full circle. So if we're dealing with 36, this is going to be 72 pi over 36. So if we have negative 37, and we add 72, that's going to give us 35 pi over 36. And if we subtract that, 72, we are going to get a negative 109 pi over 36. So these are the two coterminal angles there. With this one, it's in degrees, so we can keep it in degrees. So we can add 360 degrees, and we can also subtract 360 degrees. So if we add 360 degrees, we are going to get 580 degrees. And if we subtract 360 degrees, if we subtract 360 degrees from 220, we are going to get negative 140 degrees. Same deal over here. We want to add 360 and we want to subtract 360. So if we have 240 and we add 360, that gives us an even 600 degrees. And if we subtract, we're going to get negative 120 degrees. So really straightforward work there. Hopefully we're okay with that. Remember, you're just adding one circle. If it's in radians, keep it in radians. If it's in degrees, keep it in degrees. Okay, then graphs. Other trigonometric graphs, follow that worksheet that was handed out in class. Really, for the test, it's going to be matching and no domain and all that good stuff. With these other graphs, we have to sort of figure out how we are going to approach them and what values we're going to look at. So with this, I'm actually going to blank off this area down here, and we can graph down there. Okay, so number 17. First off, the amplitude is 1/2, and the period is 2 pi, because this is the b value is 1. So we're going to start off, if I'm dealing with 17 over here, I'm going to start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so from all these, I'm going to do the opposite of what's in there. So I'm going to subtract pi over 4 from all of these values. When I subtract them, I'm going to get negative pi over 4. Here, this is pi over 2, which is 2 pi over 4 minus pi over 4 is pi over 4. 4 pi over 4 minus pi over 4 is 3 pi over 4. 3 pi over 2 has a common denominator of over 4. So that's going to be 6 pi over 4 minus pi over 4 is 5 pi over 4. And 2 pi is going to be 8 pi over 4 minus 7 pi minus pi over 4 is 7 pi over 4. These are the new x values. So if I graph my x-axis, these are the values there. So I'm going to divide this up into fifths. So I'm going to get negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now I can draw in where the y-axis is going to be. It's going to be halfway between negative pi over 4 and pi over 4. And I know that I'm going to have an amplitude of 1/2. So that's positive 1/2, that's negative 1/2 on my y-axis. And I just need to graph this. So this is sine. So as I plug these in, I'm going to get my original values here in green. So when I plug in negative pi over 4, I get sine of 0. Sine of 0 is 0. Pi over 4 plus pi over 4 is pi over 2. Sine of pi over 2 is 1. And I'm just going to kind of go through this quickly, but as you plug these values back in, you will get these, and you just connect the dots to make a nice little sine graph. That's definitely not a nice little sine graph. So let me try that again. It's a little bit better. And there we go with that. So be mindful of that. So that'll be 17. All right, now let's look at 18. So 18, amplitude is 4, period is 2 pi over 2. So that's going to be pi. But for us, we're still going to be looking at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so we are going to do the opposite of what's in here. So first off, we are going to subtract by pi over 6. And when I do that, I'm going to get negative pi over 6. This is 3 pi over 6. Minus pi over 6 is 2 pi over 6, or positive pi over 3. This is 6 pi over 6. Minus pi over 6 is 5 pi over 6. This is going to be, if I multiply by 3, 9 pi over 6. Minus pi over 6 is 8 pi over 6, or 4 pi over 3. 12 pi over 6 minus pi over 6 is 11 pi over 6. And then again, I want to do the opposite continued. So here I'm multiplying by 2. So I'm going to multiply by 1/2. Again, just do the reciprocal of what is provided for you. And when I do that, I'm going to get my new values. So I'm going to get negative pi over 12. Here I'm going to get pi over 6. Here I'm going to get 5 pi over 12. I'll check this in a second. This is going to be 4 pi over 6 or 2 pi over 3. And this is going to be 11 pi over 12. So you can see the distance between the first point and the last point is 1 period. That's the distance of pi. So that's going to be really nice for my graph. This is negative pi over 12. That's 2 pi over 12. So there's a distance of 3 pi over 12 between them. 3 pi over 12 between these two. This is 8 pi over 12, so that's 3 pi over 12. And again, 3 pi over 12. So these are my new points. And as I plug them back into the formula, I'm going to get the original values here. So when I plug this in, first off, yeah, don't worry about that y-axis. Just graph the x-axis first. And we can graph these 5 points that I just figured out, these 5 x values. So I get negative pi over 12, pi over 6, 5 pi over 12, 2 pi over 3, and 11 pi over 12. The y-axis is going to be between here and here. So this is negative 1 pi over 12, and this is actually 2 pi over 12. So it's actually going to be closer to the negative. So maybe about there. Amplitude for this one, number 18, is 4, I think. Yep, so 4. So we can call this up 4. That's slanted. Give me a nice straight line. There we go, 4. And so that could be negative 4. And so as I plug these in, and again, I'm going to rush through this. 4, negative 4. As I plug these in, I'm going to get that nice cosine graph. And do the best I can. There we go. It's a nice little wave, and that is number 18. Okay, how much more space do I have here? All right, try to get 19 and 20 both in here. All right, so 19, actually the same sort of idea, except we are going to be subtracting 4 pi over 3 instead. Okay, so we're going to start with the original points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And what we're going to do is we're going to do the opposite. So we're going to subtract by 4 pi over 3, minus 4 pi over 3, minus 4 pi over 3, minus 4 pi. Starting to lag again. And we subtract. Okay, so, right, so 0 minus 4 pi over 3 is minus 4 pi over 3. Common denominator here is going to be 6. So this is 3 pi over 6 minus 8 pi over 6 gives us a negative 2 pi over 6, or negative pi over 3. This is, it's an ugly 3. But aside from that, this is 3 pi over 3 minus 4 pi over 3 is negative pi over 3, leading me to believe I did this one wrong. So again, this is 3 pi over 6 minus 8 pi over 6 gives us a negative 5 pi over 6. I was way off on that one. That's why we don't do math in our heads. We always write this stuff out. So that's negative 5 pi over 6. And this is definitely negative pi over 3. Here, again, common denominator. So this is going to be 6. So that's 9 pi over 6 minus 8 pi over 6 is going to give us a pi over 6. And here, this is going to be 6 pi over 3 minus 4 pi over 3 is 2 pi over 3. So the distance between these is 6 pi over 3 or 2 pi. It should just be pi. Oh, that's right. Because I did not impact this, right? So we still have to multiply by 2. I'm not finished yet. We still have to multiply by 2. The equation multiplies by 2, so I do the reciprocal. So I multiply all of these by 1/2. And what that's going to do, that's going to shrink my period down. Right now it's at 2 pi. I want my period to be at 1 pi. So when I multiply those down, I get negative 8 pi over 6, which I can reduce to negative 4 pi over 3. This reduces to negative 5 pi over 12. This is going to be negative pi over 6. And this is positive pi over 12. And this is going to be a positive pi over 3. Which this is negative 2 pi over 3. And that should all work out. So now when I go and graph, I'll do this down here. Again, x-axis, don't worry about the y quite yet. Plug in or mark your 5 points on the y-axis. So we get negative 2 pi over 3. We get negative 5 pi over 12. We get negative pi over 6. We get pi over 12. And finally, we have pi over 3. This is a negative pi over 6, which is a negative 2 pi over 12. So the 0, the y-axis, is actually going to be closer to pi over 12 by just a little bit. I can mark my little values on the y-axis there for amplitude, which here is 4. So that'd be a 4, and this is a negative 4. And we are looking at cosine. So as I plug these values in, it's going to be really nice hitting these values. You should plug these in to check. I know what the answer is beforehand, so I'm just kind of rushing through this to show you how it should look. And if the graph ever doesn't hit the point, just make the point bigger. Okay, last one. Yippee. And let's finish off with old blue. So number 20. We are going to add pi over 4 to every point and then multiply by 2. So number 20 here. We're going to start again with our original values. 0, pi over 2, pi, and 3 pi over 2, and 2 pi. And so we're going to do the opposite of what's presented to us. So instead of us subtracting pi over 4, we are going to add pi over 4 to all of these values. And when I do that, I get 0 plus pi over 4, which is pi over 4. Whoops. 2 pi over 4 plus pi over 4 is 3 pi over 4. 4 pi over 4 plus pi over 4 is 5 pi over 4. This is 6 pi over 4 plus pi over 4 is 7 pi over 4. And 8 pi over 4 plus pi over 4 is 9 pi over 4. Now what I need to do is I need to do the opposite here. So I'm dividing theta by 2. So I'm going to do the reciprocal operation, which in this case means that I'm going to multiply by 2. So multiply all these by 2. And so actually that's going to clean up these denominators just a little bit more nicely. So this is going to be 2 pi over 4, which is pi over 2. 6 pi over 4, which is 3 pi over 2. Then we're going to have 5 pi over 2. Then we're going to have 7 pi over 2. And then we're going to have 9 pi over 2. Whoops. So I graph these. Again, graphing my 5 points. And so I'm going to have pi over 2, 3 pi over 2, 7 pi over 2. That should be a 5 pi over 2. Uh, 7 pi over 2. And 9 pi over 2. Grand. Actually, you can see that the y-axis isn't actually here. It's actually going to be probably about here. So there's my y-axis. So I'm not going to actually graph to the y-axis. I'm just going to graph to this point. It's a sine function. So that means we start at 0, go up to the amplitude, back down to 0, down, and then back up. So we get this. Whoops. Drawing on this trackpad is not the easiest thing in the world, but neither is trig. Actually, that goes right there. This point is off. So again, check this out. Graphing may be one of the most difficult things, but again, with fractions, make sure you're setting up your problems right, you're finding your x-coordinates, and you're plugging in correctly. And make sure you just keep going through the rest of this and studying for your test.